The thing that we have studied so far is about the formula of derivative of the function. The next thing that we're gonna study is gonna be the technique in order to find derivative of the relation or the function. So we're gonna get the relation in x and y, and we would want to find derivative of the function y in terms of x kind of. So the technique is called implicit differentiation, and the implicit differentiation that we're gonna cover is come from section 3.5 of the book. And after that, we're gonna apply the technique implicit differentiation in order to find derivative of logarithmic function. And it's gonna be on related rate, and it's gonna be on linear approximation and differential. So for implicit differentiation, the problem begins with we have the relation x squared plus y squared equal to 25. And if you recall, this guy will give you a circle. So you would get a circle of radius 5. And we can arc for finding the tangent line to this circle. Okay, so if I ask you, so what will be the tangent line for this circle? So the thing that you need will be, you need the slope of this tangent line at the point here. So you need slope here at this point. And in order to obtain the slope, you know that the slope is the same thing as derivative of the function. So in this case, we're gonna find derivative of this function. So we need to find what is y. Okay, so we need to find what is y. So if you solve for y, it's gonna turn out to be y equal to square root 25 minus x squared, or y can be negative of square root of 25 minus x squared. Okay, so what formula can that we gonna use depending on where we gonna have the slope? However, in this case, if you just try to find derivative of this function, you're gonna find that it's gonna be y. Okay, so you're gonna just basically differentiate this guy. So you're gonna get y prime equal to, so you dip square root of 25 minus x squared. So it's gonna be 1 over 2 square root 25 minus x squared. And you dip 2x, so it's gonna be negative 2x. Okay, so this is for the first one. Or if you differentiate this guy, so you would get y prime equal to 1 over. Okay, so don't forget the negative side, so it's going to be negative 1 over square root 2 square root 25 minus x squared. Okay, and you're going to multiply by 2x as well. Okay, and you see that you'll be able to get rid of 2 and 2, 2 and 2 here, and you're gonna get negative x over square root 25 minus x squared for this guy. And the second one, you will get negative x over square root 25 minus x squared. I'm not gonna multiply this one yet. However, I'm gonna move the negative y down here. Okay, so in this case, you see that in the first case, let me have all here. In the first case, you're gonna have y prime equal to negative x over square root 25 minus x squared. And what is square root 25 minus x squared? It's gonna be just y. Okay, so this 125 minus x squared inside square root. So in this case, you may say that, hey, this guy equal to negative x over y. The answer is yes, is it actually. Okay, and you have another one. You have y prime, so it's gonna be y prime, and you see that you have also negative, so this guy will be negative of 25 minus x squared inside square root. So in this case, this guy is exactly the same as y in the second case. So you would have y prime equal to x over y as y in the second case. So in this case, you see that you have the same derivative in both cases. Okay, so you have this case, you get negative x over y. In the second case, you also get negative x over y. So you see that both of them are the same in two cases. So you may conclude that you don't need to solve two cases. Okay, so you don't need to solve these two cases. You're gonna just answer y prime equal to negative x over y in both cases. Okay, so this one will be your answer in this case. So you have, in this case, y prime equal to negative x over y, and you may plug in x and y at the given point. So here, if this point turn out to be uh, 4, 3, let's say it's 4, 3, so you just have y prime equal to 4, 3, x equal to 4, y equal to 3, uh, x equal to 4, y equal to 3. So the slope is equal to 4 thirds. Okay, so this one will be how we differentiate this circle. Okay, so for the next one, you're gonna see that sometimes it's not possible to solve for y explicitly. For example, you see you have y here and you have y here. So this guy, I would say that it's gonna be difficult to solve for y. Okay, so in this case, difficult to solve for y. How would we find y prime if we not be able to solve for y? We're gonna use the technique that called implicit differentiation. The method that we're gonna use is called implicit differentiation. We're gonna not need to solve for y. We're gonna just differentiate the whole thing without solving for y, but we're gonna think about y as a function of x, and we're gonna apply the chain rule in this case. For example, you see that when you dx of y cubed, okay, so when you dx of y cubed, and y cubed is going to be fx cubed, okay, y cubed is going to be fx cubed. So in this case, you apply the chain rule together with the power rule. So 3 will come down, and it's going to be 3fx squared, and deep inside. So in this case, you will have 3 fx squared times f prime x. So it's going to be 3y squared y prime by using the chain rule. So we're gonna just think about y as a function of x, and then we differentiate it at a differentiate as you have the chain rule. So for example, you like to find ddx of psi y. So you basically differentiate psi y, dip side you get cos, so it's gonna be cos y, and you're gonna have the inside. The inside in this case will be your y, so you're gonna multiply with y prime. Okay, so this one will be just derivative of sine y. And ddx of fy turn out to be just f prime y, and you dip inside, it's going to be y prime. So this guy is dip inside. Okay, and if you have ddx of x cubed times y squared, in this case, you're gonna see that this guy is the product. So this one is the product. So you have the product between x cubed and y squared. So you're gonna try to differentiate this one by using the product rule. So it's gonna be the first derivative of the second plus the second derivative of the first. So in this case, it's gonna be x cubed, and it's gonna be 2y, y prime plus y squared, and dx cubed is going to be 3x squared. Okay, so this is how we find this derivative. So if you not quite follow, let me highlight you something. So this term turned out to be this green term. Okay, and ddx of x cubed is just 3x squared. Okay, so this is how we differentiate implicitly. It's called implicit differentiation. So you just differentiate and you think y as a function of x. Okay, so you just think that you have y as a function of x and apply the chain rule. I do many examples, and this one is not difficult to do, and it's going to be an important technique in order to find derivative of the function. Okay, so you have y prime. Okay, so you have y prime given by y prime. So you like to find y prime of x cubed plus y squared. Sorry, it's x cubed plus y cubed equal to 6xy. So in this case, you're gonna have to differentiate the whole thing. So when you like to differentiate the whole thing, the thing that we're gonna do is gonna be, so you basically dip the whole thing. So in this case, it's gonna be, you're gonna dip x cubed plus you're gonna dip y cubed, and you're gonna dip 6xy. So you see that, okay, I'm gonna just change the color a little bit. So this one, I'm gonna use my green color. Okay, and I'm gonna use the red color for this term. Okay, in order to distinguish each term and each calculation. So I'm gonna use 3 color in this case. So for the green one, you see that dip x cubed is gonna turn out to be 3x squared, pretty clear. And you're gonna dip y cubed, so it's gonna be 3y squared, y prime, okay? And you dip 6xy, so it's gonna be 6, and you dip xy, so it's gonna be the first derivative of the second plus the second derivative of the first. Okay, so derivative of the first is equal to 1, so you may write 1 here. Okay, so this is what you have. Okay, so you're gonna differentiate this one, and you're gonna see that you're gonna get how many terms. So you get 4 terms. So you would have 4x squared, 3y squared, y prime equal to 6xy prime plus y. Okay, so this one is the first step. The first step that I say is going to be dip both sides. Okay, so you differentiate both sides. This is what you have so far. Okay, so in this case, you're gonna gather y prime on the same side. So we're gonna gather y prime on the same side, and the term without y prime will be on the other side. Okay, and the term without y prime on the other side. Okay, so you gather y prime on the same side and the term without y prime on the other side. What does it mean? It means that you're gonna gather this term and this term together on the same side. So you get 3y squared y prime minus 6x y prime equal to y, okay, and minus 3x squared, okay. And you see that you'll be able to pull out y prime, okay. So you'll be able to pull out y prime. So you get 3y squared minus 6x y prime equal to y minus 3x squared. So for this one, you're gonna get y prime equal to y minus 3x squared over 3y squared minus 6x. Okay, and this one you're gonna have y prime that you're looking for. So the second step that we did here is called solving for y prime. So it's going to be our second step. So we solve for y prime. Okay, so for implicit differentiation, it's going to consist of two steps. The first step will be you're gonna differentiate both sides. Okay, so you have two steps. The first step will be you differentiate both sides. So you just have many terms. And the second step will be you gonna solve for y prime. Okay, so this is what I did. And you see that you gather y prime on the term on the same side, and you gonna gather the term without y prime on the other side. For the next one, the curve is given by the equation 3y root x minus y squared over x equal to 2, and you want to find y prime. Okay, so you want to find y prime, and the question also asks you to find an equation of the tangent line. When you read this one, it's going to be tangent line. So tangent line, so you need y prime for sure. Okay, so you need y prime. So you need y prime at what point? You need y prime at 1, 2 in this case. So in this case, you're gonna differentiate. I'm gonna use three color again. So it's gonna be 3y root x, okay, prime. And the second one will be negative of y square over x prime equal to, you have the last guy, which is 2 prime. Okay, so in this case you differentiate each of this one. So you see that the green guy, you need to use the product rule. Okay, for the blue guy you will use the quotient rule. Okay, so in this case you get the first, okay, 3y derivative of the second, so it's going to be dip 3y and root x, so it's going to be dip root x, so it's going to be 2 root x plus the second, which is root x derivative of the first, so it's going to be 3y prime. Okay, so this is what we have for the product rule. So this is what we have. And the second one will be the bottom derivative of the top 2y prime minus the top derivative of the bottom, and everything will be over the bottom square. Okay, so it's going to be the bottom square, so it's going to be x square. Okay, equal to dip 2 is going to be 0. This guy is constant. Okay, so it's going to be dip constant equal to 0. Okay, so we need y prime, and we need y prime at 1, 2. So this is what we need. Okay, so in this case, you see that we're going to be able to find y prime at 1, 2 by finding y prime first. However, in this one, I'm going to say that we don't need to solve for y prime. Okay, we just put x equal to 1. Okay, so we just put x equal to 1, y equal to 2, and so, okay, and we have y prime at 1, 2. Okay, so we just put x equal to 1, y equal to 2. So we don't need to solve for y prime like like in the previous example. However, we're gonna put x equal to 1, y equal to 2. So we would put x equal to 1, y equal to 2. So it's gonna be 3 times 2, and it's gonna be 1 over 2 root 1 plus root 1 3 times y prime minus, you have this guy x equal to 1, so it's going to be 2 times 2 y prime minus 2 square over 1 square equal to 0. Okay, so in this case, you're gonna solve for y prime. Let me highlight y prime first. Okay, so in this case, you get 3y prime. So this guy, you get 3y prime. Okay, and this guy, you see that it's gonna be minus 4y prime. Okay, and it's gonna be plus 4. Okay, and for this term, it's gonna be plus 3. And you see that you have y prime and you have y prime. Okay, so you're gonna have your negative y prime equal to what, 7. So it's gonna be negative 7. So you would have y prime equal to 7 in this case. Okay, so you have y prime equal to 7. So you get the slope of the tangent line equal to 7. Okay, so you get y prime equal to 7. So this one will give you the slope, and this one will give you the point. Okay, so you have the point 1, 2. So you're gonna have the tangent line. So the tangent line is given by, so it's going to be y minus 2 equal to 7x minus 1. Okay, and this one will be your y equal to 7x. Okay, 7 minus 1, so it's going to be negative 7, negative 7 plus 2, so it's going to be negative 5. Okay, so this one will be your solution. Okay, so this one will be your tangent line. The next one, you have x squared minus 2xy minus y squared equal to 9. And this one, you see that it's not possible to solve for y explicitly. So we gonna differentiate both sides like we have. However, for this one, the question does not ask you to find y prime. It's ask you to find y double prime. So when the question asks you to find that y double prime, it means that you're gonna have to differentiate the function twice. So you differentiate this guy, okay? So it's gonna be you differentiate this term, okay? So you have 2x, okay? And you differentiate this term. So it's gonna be, you have the product rule, right? So this one is product. So in this case, it's gonna be negative, and the first derivative of the second plus the second derivative of the first. Okay, so that the second term, and the third term, you see that you have negative y squared, so it's going to be negative 2y. Don't forget y prime equal to 9. Okay, so it's not 9, so you differentiate 9 also. So differentiate 9, you would get 0. Okay, so constant. Okay, so in this case, this is how we have form what form y prime. So you see that we be able to divide by 2 both sides in order to ease the calculation. So it would give you x minus xy prime plus y minus y prime, okay, equal to 0. Okay, so this is the thing that we have from first derivative. Now the question asks you the second derivative. So in order to have the second derivative, you see that we have a relation between x, y, and y prime. So in order to find the second derivative, you're gonna dip this guy again. So we're gonna differentiate this guy again. So you have this one differentiate. So you're gonna just dip this term. So you dip x, you get 1. And you dip xy prime. So you have the first derivative of the second. So it's gonna be y prime prime like this. Plus the second derivative of the first. Okay. And you have y prime. Okay. And this guy, you get the first derivative of the second plus the second derivative of the first. Okay, so this one is also a product rule. The term that most confusing will be, I believe that it's gonna turn out to be this guy. Okay, so that you have to apply the product rule. Okay, so this one is normal thing that student will confuse. Why do we have this one? So let me explain this term. So in order to differentiate this guy, the thing that I use is going to be using the product rule. And the thing that I have to explain will be, you see that this is the first and the second. So it's going to be the first derivative of the second plus the second derivative of the first. Okay, so this is what we have. And you see this term come down is y prime. Okay, and you see that we may simplify this one into, this guy is going to be x y double prime plus y prime. Let me pull out the parentheses, so you're going to get this one plus y prime, okay, plus y prime, and minus, and you see that this guy is y double prime, so it's going to be y double prime. This one is y double prime. Okay, so I underline them, and y prime times y prime turn out to be y prime square. Okay, so this is what we have, and this guy equal to 0, equal to 0. And you see that we gonna solve for y prime from this relation. Okay, so we're gonna solve for y double prime from this relation. So you're gonna do the same trick. So you're gonna move y prime, sorry, y double prime on the same side. Okay, so you're gonna gather y double prime on the same side, and you're gonna gather the term without y double prime on the other side. So in this case, gonna be 1 minus this guy is gonna become, I think I make a mistake here. Ah, sorry. So this one is negative. This one is negative and this one is negative. Sorry about that. So this guy is negative, negative, and negative. So in this case, this guy is 2y prime, okay? And you plus y prime square. And you have the other term on the other side. So it's going to be xy double prime plus y double prime, okay? So in this case, this one and this one, okay? So in this case, you would get x plus y double prime, and you get 1 minus 2y prime plus y prime square, okay? So you would have y double prime would be 1 minus 2y prime plus y prime square over x plus y, okay? And this one will be your final answer, okay? So this one will be just this final answer. I don't need this box, sorry. So this is the whole thing for this calculation, okay? So you see that you find the first derivative first, and then you find the second derivative. Let me emphasize on the calculation a little bit. So here to here is gonna be first derivative, and this guy is gonna be second derivative, okay? And you just solve for y prime. Let me, this one is not second derivative yet. The second derivative here comes to here. So this one is second derivative. Okay, so you have to differentiate 2 times in this case. Okay. The most confusing will be this term also. So if you have problem, you should have problem with this term. Y prime times y prime, okay? Y prime times y prime is y prime square, okay? So this is another important thing that you may confusing, okay? So you may confuse on this, you may be confused on y prime times y prime equal to what? It is equal to y prime square, okay? The next one, we would want to find the derivative of this guy. Okay, I make a mistake here. This one should be the minus sign. Sorry. Let me erase this one. So this one should be the minus sign. So you have sine xy equal to e to the y tan x minus x square root x plus y to the fourth, and you would want to find the derivative of this function. So you basically, you're gonna differentiate 3 terms, okay? So we're gonna differentiate first, you differentiate sine xy. So you differentiate sine xy, so you dip side, you get cos xy, and you dip inside, so it's gonna be xy prime. So that is on the left side. For the right side, you see that you're going to differentiate e to the y tan x. So it's going to be the first derivative of the second plus the second derivative of the first. Okay, so that for my second term. And my last term is going to be the chain rule for the power rule. So it's going to be 4, and you have root x plus y, and to the third, let's write down 4 minus 1, and you have root x plus y prime. So in this case, you're gonna have this term. Okay, so this term equal to this term, and you differentiate the green guy, you would get the green one. And you have the pink one. Okay, so this one is derivative of the pink one. Okay, so you have like a 3 term, so you dip this gun, so you differentiate. So in this case, you're gonna simplify, or you're gonna dip them out. So it's gonna be dip xy prime. So we need to differentiate this term. Okay, so we need to differentiate this term. So it's gonna be, I think it's too much. Yeah, so it's gonna be cos xy multiplied with the first derivative of the second plus the second derivative of the first. Okay, so this is how we have, and you differentiate tan, you get sec square, and you differentiate e to the y, so it's going to be tan x, and differentiate e to the y, so you get e to the y prime. Okay, and finally you get square root x plus y cube. Okay, and you dip root x plus y, so it's going to be 1 over 2 root x plus y prime. Okay, so this one. And now we're gonna solve for y prime. Okay, so we're gonna solve for y prime. Let me write what I'm doing. So we're gonna solve for y prime. So we're gonna solve for y prime. So you have to take a look where you have y prime. So you have y prime at this term. You also have y prime here. You have y prime 3 terms. Okay, so you're gonna gather them on the same side. Okay, so you're gonna gather them on the same side. So in this case, be careful a little bit. It's gonna, you need to multiply cos xy to each term first. So it's gonna be cos xy multiplied with x times y prime. Okay, so this is one term. Another term on the right side will be negative tan x e to the y prime. Okay, and you have the last term come from this guy multiplied to this guy, and this guy multiplied to y prime. So it's going to be 4 square root x plus y cube y prime. Okay, so it's gonna be 3 terms. So this guy, and this guy. So this one, you gather them on the same side, and you're gonna move the rest of the term to the other side. For the other side, this one is gonna have equal side, right? And you see that it's gonna become this term that will be on the right side, and this term that will be on the right side. Let's write them down first. E to the y sec square x. Okay, it's on the right side. And you have negative 4 square root x plus y cube, and you multiply here, it's gonna be 2 over root x. Okay, so it's gonna be this term for me. And finally, you're gonna have to move this term from the left side to joy. So it's gonna be y times cos xy. Okay, so it's gonna be y times cos xy. So in this case, you're gonna have y prime equal to, okay, so y prime will be equal to, let me write it here. I need space. So in this case, you're gonna have y prime equal to, so you're gonna see that this one you'll be able to solve for y prime very simple. So you're gonna just have copy everything, e to the y sec square x minus 2 over root x plus y cubed and minus y cos xy. Okay, and everything will be over, okay, everything will be over cos xy times x, so it's gonna be x cos xy minus tan x e to the y, okay, plus 4 square root x plus y cube. Okay, so this is how we have solved for y prime, and this one will be your y prime that you're looking for. Okay, so it's kind of messy a little bit because we have many terms in this case. The next one, you have 2 to the y over x, 1 over x cos y. So you want to find y prime. Okay, so you want to find y prime. Again, we gonna basically differentiate this guy, okay, without solving for y. So you see that on the left side, you would dip 2 to the y over x. So 2 to the y over x is going to be 2 to the y over x log 2. And you dip inside, so you have y over x prime. Okay. And you dip 1 over x. So you dip 1 over x is going to be, let me write this one smaller a little bit. So it's going to be 2y over x log 2, and you dip y over x, okay? And you dip 1 over x, so it's going to be negative 1 over x squared, as I asked you to memorize. And dip cos, you get negative sine y prime, okay? So in this case, you get 2y over x log 2, and you dip y over x. Okay, so you dip y over x, so you would get the bottom derivative of the top minus the top derivative of the bottom over the bottom square. Okay, and you get negative 1 over x square and plus psi y times y prime. Okay, and you see that you have many terms, and in order to solve for y prime for this one, you're gonna multiply the whole thing by x squared in order to ease the calculation. So you multiply the whole thing by x squared, so you see that you'll be able to get rid of 2x squared on both sides, and you're gonna end up with 2y over x log 2, and you're gonna have xy prime minus y equal to negative 1, and don't forget to multiply x squared to the last term, so it's gonna be psi y prime. Okay, and you see that you need to solve for y prime, right? So it's gonna be y prime y prime. Okay, so this one, and you gonna gather the term with y prime on the same side, so you get 2y over x log 2 multiply with x, okay, multiply with y prime, so it's going to be xy prime, and you have another term which is x squared psi y, okay, multiply with y prime, equal to the term that you have without y prime, so it's going to be 2 to the y over x and log 2 multiply with y, okay, multiply with y and minus 1, okay, so this is the term that you move from the other side, and then you're gonna solve for y prime by just have the quotient. So in this case you get y prime, so you get 2 to the y over x log 2 times y, okay, minus 1 and everything over 2 to the y over x log 2 times x, okay, and you have minus x squared psi y, okay, so this is how we have the final answer, okay, so it's gonna be kind of like a not quite easy. I'm not gonna say easy. You have to find derivative of the quotient. Okay, so this one is from the quotient rule. Okay, and the rest will be just implicit differentiation. Okay, so this is we have. Okay, so one last thing, we be able to use the implicit differentiation to find the derivative of the inverse trigonometric function. So we're gonna have y equal to arcsin x. Okay, so we are having y equal to arcsin x, and we would want to find derivative of arcsin. So we're gonna solve this guy in terms of y. So this guy, you'll be able to solve sine y equal to x. So you have sine y equal to x. And when you have sine y equal to x, you're gonna have cos y equal to square root 1 minus x squared. Why we have that? Because you have cos square y plus sine square y equal to 1, right? So you would get cos square y equal to square root 1 minus sine square y, okay? And this guy will be cos y equal to square root 1 minus x squared. And then you're gonna differentiate both sides. So you differentiate this guy. So you have sine y equal to x. So you differentiate this guy. So you dip side, you get cos y dy dx equal to 1. And you're gonna, so you this one, you see that you differentiate implicitly. Let me write here to here. Okay, so this one, the first step. The second step, you div implicitly. Okay, and you get d dx of sine y equal to d dx, and dip side you get cos, okay, dip side you get cos, and dy dx equal to 1. So you have dy dx equal to 1 over cos x, and 1, sorry, 1 over cos y, okay, so you solve for dy dx, okay, so you solve for dy dx, so you have dy dx is the yellow guy, okay, so you have dy dx equal to 1 over cos y, and what is dy dx? Dy dx turn out to be d dx of arc sine x. So this guy become d dx of arc sine x, d dx of arc sine x. Okay, so it will be d dx of arc sine x because y equal to arc sine x. Don't forget that. Okay, so this one, and you have d dx of arc sine x. Okay, so you dip arc sine is going to be 1 over square root 1 minus x squared. Okay, so this one, and don't forget we solved for cos y already. So cos y is this term. Okay, so cos y equal to square root 1 minus x squared. Okay, so this one you have the formula for dip arc sine. So you dip arc sine, you get 1 over square root 1 minus x squared. Okay, so dip arc sine is 1 over square root 1 minus x squared. You may think that hey, it's not quite make sense why this guy is turned out to be not arc cos. Okay, so that dip sine equal to cos and dip arc sine is not equal to arc cos. Trust me on that. Okay, so this one is going to turn out to be another formula that is kind of, I would say it's difficult to understand because it's involving algebraic identity a lot. However, you may just memorize this one, that's fine. Okay. The thing that you should understand will be this formula come from implicit differentiation and trigonometric identity. Okay, so the important part turned out to be your implicit diff and this trigonometric identity. That will be two places that you may have to study. And again, you need to memorize dip arc sine equal to 1 over square root 1 minus x squared. Similarly, we can show that if you like to dip arc cosine, you do the same thing, okay? You're going to be able to show that dip arc cos is turned out to be negative 1 over square root 1 minus x squared, okay? And for arctan, you have y equal to arctan x, so you get tan y equal to x. So you're gonna have, okay, so you're gonna have tan y equal to x, and in this world you have sec square y equal to 1 plus tan square y. Okay, so you have sec square y equal to 1 plus tan square y. So you get sec square y equal to 1 plus x square. Okay, so you have sec square y equal to 1 plus tan square y, and you have tan square equal to x square. Okay, so this guy is turned out to be this relation, and you're gonna differentiate. Okay, so here, like we did in the previous case, so this one is your first step, this one is your second step. So you diff implicitly. Okay, so you dip tan y. Okay, so you dip tan, you get sec square y and dx. So you dip tan is sec square. So you use the chain rule. So you have dip tan is sec square, and you have to dip inside. So you have dy dx. Okay, so in this case, you're gonna solve for dy dx. So you solve for dy dx is gonna be dy dx equal to 1 over sec square. And the sec square guy is the green guy. So this is another important formula. This is dip arctan. Dip arctan x, okay, differentiate arctan x is gonna turn out to be 1 over 1 plus x squared. Okay, dip arctan x is 1 over 1 plus x squared. So this one will be important formula, and we'll be able to show that dip arc cot x equal to negative 1 over 1 plus x squared, and the similar technique here can be used to show that dip arc sec x equal to 1 over absolute x square root x squared minus 1, and dip arc cosec is going to be negative. And in the application, we not quite use absolute value. So sometimes you may just see me write down just x, that's fine. Okay, so we not quite use the other side of x, so we not quite use the opposite side of x, so we're not gonna use absolute value in the derivative. Okay, let's try to differentiate this guy. Okay, so you have y equal to x cubed arcsin e to the x. Okay, so y equal to x cubed arcsin e to the x. So you just use product rule. Okay, so this one is the product rule. So you have the first derivative of the second. Okay, so you dip this one. Let me write this one smaller. So you have y prime equal to the first derivative of the second plus the second derivative of the first. So in this case, you gonna get x cubed and deep arcsine is gonna be 1 over square root 1 minus e to the x square. Okay, so this is deep arcsine and this one is the function inside, right? So this one is the pink guy. So this one is the pink guy, so it's gonna be here. And don't forget to dip e to the x. Okay, so you dip e to the x prime plus psi e to the x and dip 3x, dip x cubed, so it's gonna be 3x squared. So in this case, it's gonna be x cubed. Okay, so let me draw the square root line first. So it's going to be just dip e to the x, it's going to be e to the x square root 1 minus e to the x square, okay, plus arcsine e to the x, okay, times 3x square. Okay, so this is how we have for derivative of the product rule involving the arcsine. Okay, the next one, okay, the next one is gonna be 3 over 10x. This one is easy. This one is 3 over u. Okay, so this one is 3 over u. And when you dip this reciprocal, it's gonna be y prime equal to, I told you before that you just memorize this one is tu square du dx. Okay, and then it's gonna be just negative 3 over arctan x, okay, and dip arctan is going to be 1 plus x squared. Okay. Last one, you have x over 2 plus arctan y squared equal to arcsec 3 over x, okay. So in this case, you're gonna find derivative both sides implicitly. So you get 1/2. Okay, so you get 1/2 for the first term. Dip arctan y square, so it's gonna be 1 over 1 plus y square square and y square prime equal to dip arcsec. Okay, so it's gonna be, like I said, it's gonna be absolute 3x plus 2. If you don't have absolute value, they should be fine. And you have square root 3x plus 2 square minus 1. Okay, and you dip inside, so it's gonna be prime like this. And this one will be 1/2 plus 1 over 1 plus y to the 4th. Okay, and you dip this term is gonna turn out to be 2y prime equal to, okay, so you have 3 over absolute 3x plus 2 square root 3x plus 2 square minus 1, okay, and then what, and then we're gonna put x equal to 0 and y equal to the fourth root of 3 into the thing that you have computed so far, okay, so you're gonna put x equal to 0, y equal to the fourth root of 3. So in this case, you get 1/2 y equal to the fourth root of 3, right? So it's going to be to the fourth root of 3, and you have 1 plus the fourth root of 3 to the fourth, and you have y prime equal to 3 over 2 square root 3 times 0 plus 2 square minus 1. Okay, so in this case, you're gonna solve for y. Okay, let me, you're gonna solve for y prime, but you're gonna solve for y. So in this case, what is this guy? It's gonna be 3, and you have 2 on the bottom, and you have root 3 on the bottom, and 3 and root 3 cancel each other, so you would get root 3 over 2, okay, and you have this 1/2 plus, okay, so this guy will be 2 root 3 over 4, not the root 4 of the fourth root of 3, sorry, and here is going to be 1 plus 3, okay, y prime equal to root 3 over 2, okay, so this one you're gonna solve for my y prime, okay, so for y prime is gonna be what is my y prime, so you need to have root 3 over 2 minus 1 over 2, okay, and you multiply this one by 4 over 2 the fourth root of 3, okay, so in this case you see that 4 cancel with the whole thing here, so it will be just root 3 minus 1 over the fourth root of 3, okay, that's it, okay, so this is the thing that we have. The next topic that we're gonna study is gonna be about deep log, and we're gonna learn about derivative of logarithmic function, and we're gonna use the technique called logarithmic differentiation. Okay, so that's what we have in the next time video. Okay, so that's all for this one.